Okay, so I'm just going to make this video here. I'm going to quickly press run so you can see that it does in fact run. It takes a little, there we go. It's all works there, and I'll just walk you through what this means. Okay, so it starts off with creating an environment with size 200. This is referencing this code here, and it just creates it with a size. So this is the maximum size of the grid which I'm working with. In this case, 200, because I fed it to 200. Now I initialize a task assigner. This is a very, very simple constructor, just here. And as you can see, that works. Well, you can't see that yet. And control environment create task. In that environment create task is, I can find, here it is, which is it creates a task with two pickup with pickup and delivery at two random locations, which are within the grid size. So this is using the location method class, which is here, which I've done as a way of having all the locations be done consistently across the program as a hybrid. And yes, so here it's gives the task the ID and initializes the task and gives the task assigner the add task. Now add task is here, and it sorts it adds a new task to the task list or the max ID, and the ID doesn't really matter at this point, so I'm not too sure about that. It's not that important, but this is important. It sorts the task by deadlines using this code, then sorts the deadline, because if you don't sort the deadlines, the whole thing stops working after one or two iterations, and then sorts the tasks by deadline, which you can see works here because the 100 is first, then when I add 50, 50 is first, then when I add 300, 50 is still first, and task 1 deadline 50. That's this. Okay. Now this is the task and task state. So task state, these 5, these are in an FSM on my project report as well, and it only allows movements in deliver. So start with all tasks are initialized with the ordered state, which is here, and only state transitions which are legal on the finite state machines are allowed. For example, you cannot go from ordered to delivered. You can only go from collected to delivered. So any other one, it won't work when you do it. And I've tested that by going into delivered, and it's still ordered because that's not a legal move, so I didn't do it. But if you go collected, ordered to collected is a legal move, and so it has done it, because if ordered, it's collected, and so now it's collected. Okay. And this is a test of the location. These are two very nearby locations for the reason of me wanting to have it be very obvious that it worked with this. So here it's 5, and to get distance, location. But if I go in location, that's just doing the Pythagorean theorem. This probably doesn't need to be abs because I'm squaring it, but it is anyway. And yeah, it's square rooting it. That's just Pythagoras to get that. And yes, this is testing the creation of drones, and that the drones are created. So spawn drone is done by the environment, which if I can find here, and it's just creates a drone at a random location. And with the target will not be in the final version, but I needed it as a spoof value for a test of finding the target, which I will get into later. And it calls it the task assigner and tells it to add drone. If I go into task assigner, this just adds it to the end of a list of drones, which starts off as empty, which is here. This is basically the same program as add task, but way less comp. But we're doing less involved things, so I haven't felt the need to test it with multiple, as it's the same thing. Yeah, this is no properties because the property is private. There are actually properties. Now this is get location and facing. So if this is the location of the drone, 139 and 63, and I've given it the target 100, 100, because that allows testing of multiple different potential locations that it can be. And if I go, it then finds facing, which is the angle it needs to head towards to go, and I've done that as I've explained in the task in the report. This is done in the standard nautical way, where 0 and 360 degrees both represent dead north, 90 represents east, 180 represents south, and 270 represents west. So this would be going northwest, as it is greater than 270, but not as big as 360. Which I will go into this code as well. So find facing. This just gets the x and y's, so they're all together. And if I've set it so that if they are the same, it's just faces head due north, because sometimes the drone might be directly on top of the target. That doesn't really mean much. And if it's heading, this is if the y is greater than the target's y is greater than the drone's y coordinate, then this is more northerly, and if it's got the same x coordinate, it needs to go direct north. This uses the right angle triangle Pythagorean to get the proper angle using the two sides, and trigonometry is opposite over adjacent, but it has to do it in tan. It does it with the tangential rule, and I've converted it from radians, which it automatically does, to degrees for the sake of readability and simplicity. This is if it's heading directly east. This is, well, if it's this will produce a value which is less than 90. Obviously, if it's in these cases, the reason I've hard coded them is it doesn't form a triangle because there's just the one line, just the one side. But in this case, it would be less than 90, and I need to adjust to get the actual angle, which is hence these elifs. And this is just pretty consistent across the whole thing. I've done them north I've gone in the clockwise fashion just for readability there. And as you can see, this has what? This is y is greater than, sorry, the x is less than, so it's going west, and the y is greater than, so it should be going north, and that is in the northeasterly direction. This test will further prove it as well. So this I will run through before I show you, because otherwise it may just be in a bunch of numbers. And first it takes off the battery level for the travel, because this is as far as it's gone in a second, and so I take off the battery usage per second. Don't do anything with that yet, but I will. And this means it goes straight north if it's got there. And this is again using trigonometry, in this case SOHCAHTOA. And get opposite and get adjacent are functions here, and sine and cos, because SOHCAHTOA and the speed is the hypotenuse. And this is if it's 90. If it's 90, it's a nice simple case. Less than 90. If it's 90, it's even simpler. And this is 180, where it's opposite and adjacent. This is the special case because in the southwesterly direction, the triangle formed so that the adjacent was the x-axis and the opposite was the y-axis, whereas coincidentally it's been the other way around for all the others, which I mainly bring up as a source of curiosity. And this is the one that we will be using here. because of the chance of the way it works. It's set with a random direction, which means that it has to work on all four to really pass the test consistently, and it finds the facing at the end in case of missing any valuables in the decimals, and this ensures that it will readjust. And also, in case there's wind, which I will model as blowing it off course in the x and y axes, which will mean that I need to recalculate the heading. I'm thinking of changing the facing to heading as it's more the navigational term. Target is also set as object targets, so needed for this. And the simplest way of deciding whether it's arrived without having issues of it not reaching the exact location was to set a delivery radius by which it was considered in the exact location. And I have done that with a radius I've set it as 5. It is adjustable in case that was something that was decided that it would be a good idea to change, and that keeps it from being a magic number. And it also made sense from a delivery perspective that the radius would be there within 2 meters is the same as being there if you're delivering to someone's house or outside, because it's in the immediate area, so it's not really the problem. Yes. So, and this is it going through this for loop, it's traveling. So as you can see, it's going closer and closer to 100 at the proper rate for travel until it gets within 5, at which point I've just set it to be there. And this is testing the charging points. The spawn charging point is extremely similar to spawn drone, but less complicated, where I add the charging point to task assigner, and task assigner keeps a list of points which starts off as empty. It's just a list of locations because that's all the charging point needs to be, really. And charging points, let's get, I want the add. It's just adds it to the end of the list, and it goes through every drone in the list of drones it has and updates their list of charging points as well. And if I go to update charging point, which is around here, it just sets it to the list it was given, which is simple. And yes, that is the tests, and yeah, that's over there.